Hello and welcome to Objective-C programming course. This is lecture number 8, and in this lecture we're going to cover archiving and saving and loading your data into a file. So you have this application we were working on. It's that simple table view application with 2 columns, and last time we have added undo and redo capabilities, and that's kind of cool, but we still limited by the lifespan of this application, and once we close the application we lose all the data. And most of the time, especially if you are doing and if you are making a document-based application, but still in most of the cases you want to save files so that you can load them later, or move those files or copy those files, send those files to someone and work with the same file using another instance of your application. So in this lecture we're going to cover everything we need to save and load data into a file. But before we go on to actually saving and loading, we have to understand the simple idea of archiving. So you have an object, and object is purely programmatical concept. Because when you think of an object, you think of source code, you think of an implementation of a class you have. But when you run your application, if you just take a look into your application executable, you will see something unreadable. That's because your program is compiled into actual bytecode or some format which is executable by your operating system. And none of that source code is there. You won't see your names of variables and the data you were working with and all those classes. That source code is lost, but you still have the data, of course. You still have all the functionality. Now, if you want to save your object somehow, one of the ways you could do it inside the source code is, well, save the source code in some form. And if you were working with JavaScript a lot, you probably know about JSON. It's a format of saving your objects as a text. And it comes really handy because if you have a computer and you created some object in your browser, let's say it's still JavaScript, and you want another computer to get the same object, you could just convert this object into a string, sort of like a textual description of the object, and send this string, which is just a simple string. There's nothing to it. It's not an object by then. It's just number of characters. Send this number of characters to another computer and then convert it back into an object, because it has everything you need. It has the names of the variables and values of those variables. So you can create an object from a string. A similar idea, but not that nice because you won't see strings, is serialization into bytes. And if you're coming from Java world, if you were doing serialization in Java, you know what I'm talking about. If no, then this is still simple. You probably read the whole slide while I was talking, so idea is simple. You have an object and you just convert this object into bytes. You do it in such a way, following some format, so that some other time you can convert it back into an object and get this object and work with this object. You can send this series of bytes over the network, but the most wonderful part is it's a series of bytes, meaning if you sending it, let's say, over the network, then the other side of the receiver starts receiving these things, these bytes, and by the time you finish receiving, it has everything he needs. So he can kind of start working on the information he gets. And this series could be big or small, but he gets something every second or something like this. But don't think about this now. Just think of archiving is a way of converting your object into bytes. So if you convert an object into bytes, you also have to convert everything you have inside the object. And since we have this wonderful object-oriented stuff, we could have a lot of objects inside another object and stuff like that. So you need to convert everything inside there. The class we will be using, and yes, of course, well, if this is a task, we already have something for this task. So we don't have to worry about serialization or archiving in the most fundamental way. We have everything we need in the Objective-C libraries. So another class from NS wonderful world is Encoding. This is not actually a class. This is an abstract class, but the thing is we have to implement two methods in our application if we want our object to be able to archive and unarchive. So one method is init with coder, and it takes a coder, which is that series of bytes. It reads the data from the coder and saves it into your instant variables. So if you have a series of bytes, you have to write the method to convert the series of bytes into your object. In other words, get all those variables and write the values of those variables inside the object. And the other way is, of course, encode your variables. So if you are an object, you should be able to encode yourself all your inside variables into a series of bytes. In other words, into a coder. So we won't see the instances of this class anywhere because this is an abstract class. So we won't be able to create variables or instances of this class, but we don't have to. So to encode something, we need to implement this function. So if we want to encode an object, we are going to call this method, encode object for key. The main thing here is the key. If we are encoding some object, we are converting it into series of bytes. And inside that series of bytes, if you just look inside a series of bytes, it's just ones and zeros. You won't be able to distinguish between which part is your object. So you need to have some key so that when you load that object and you specify the key that represents your object. It's just like a dictionary. So if you call this method and you pass it an object which you want to encode, that object should implement those two methods. But at least that first one, init. Encode, because we are encoding. So the second method should be implemented. It will be called, and the object will be converted into a series of bytes, and then be kind of saved in the series with this key, a key. And the key is just a string, just like with the key value encoding. This is just a string key. If we want to encode primitive values, like a boolean or double, we have those methods as well. It's encode bool, encode double, etc. for a key, and it's the same idea. They already have the way of encoding, so we of course don't have to write anything. We can just use it right away. So let's just take a look at our application and add the encoding capabilities to our person class. So let me go back to my Xcode, and I have this application, called it remover because, well, I don't know, I was thinking about removing people, not adding them. Okay. So just to remind you, this is that application with people and expected race, etc. So I want to be able to encode my person, and if I'm going to do so, I have to tell the compiler that I am going to adopt the NS coding protocol. So this is that protocol that I just showed you that tells us I have to implement two methods. So I'm adding to my header file of person the NS coding protocol. So now if I go to person, it should start saying incomplete implementation. It's that because I don't have those two methods implemented. So let's implement it. First is encode with coder. So that method doesn't return anything. Of course, Xcode tries to autocomplete, so I have this thing. So now I have to specify what parts of my object I want to encode. Because, well, sometimes we have a lot of data, but the data that actually matters that we want to encode might be just part of that data. In our case, only data we have is the name and expected race, and both of them are important, so I want to encode and save both of them. So I will make two calls. So the coder I'm using is here. So let's say a coder encode object, and my object is a string, the NS string, the name. I'm not using a primitive encoding because I'm saving a string, and string is an object, it's not a primitive type. So I have the name, and the key I'm going to use is of course the same, and I'm going to create the NS string on the fly and call it the key. Oh, I'm sorry, the name, of course. So that's one. And another one will look just the same, but now I want to encode a float value because my expected race is a float. And the key will be, well, nothing fancy, expected race. Now the key is just a key. I can use any string here. The important thing is when I'm going to load, I have to use the same keys because this is the key I'm going to reference. So I can just write anything here, but so to make it simpler, I'm going to use the same name as my variable. So this method will be called anytime something in my application tries to encode a person. And it will successfully encode a person and convert all those values of the name and expected race into a series of bytes. And this is still useless because encoding is fine, but I need to decode that at some point. And the place I'm going to decode it at is the same class. Because if I want to decode, that means I want to get that data from the series of ones and zeros, get those names and expected race, and apply them to myself, to the object I'm inside now. So I need to implement another method which will return an ID, meaning it will return itself actually. It will return an object which is self. And that method called init with coder, and I'm using a decoder now for the coder because this time I'm going to decode my stuff. But again, this is just a name, I could use anything here. So here is the thing. If I created my person class and I inherited from some other class, and that other class supports archiving, then I should have been calling the encode, in this case, of my superclass, something like super encode with coder, and just pass it the same coder so that my superclass is being encoded first, and then I am going to be encoded. And I should have done the same here. If I start encoding, I should first ask my parent to encode itself and then encode my stuff. This is what you're going to do if you have a class which supports archiving and then you create a subclass of that. You should always call the parent, because something inside you is from your parent. Now, that sounded really bad, but in this case, we have an exception because we are inherited from NS object, and NS object does not support those things. NS object is too generic to support those things. So we're not calling a super, but we still have to initialize. Now, why? Because if we are encoding from a series of ones and zeros, that means we're basically creating another person, because the person we are at right now is lost. So we are going to create a new person and get the name and get the data of expected race from the coder. That means we still have to initialize this the same way we initialized our class right here in the actual designated initializer. So now all I have to do is get the stuff from the coder. So in the same way, I'm going to ask if that was successful. If self is something, it's not null. Then I get the name to be able, to be equal to a decoder, and decode object for key and pass that key, this one, the name. So this thing will get the data by the key of the name, and since here we saved the name, it will be here. So we will be able to load it in an instance variable and do the same with expected race. That will be a decoder, decode, of course, float for key, and the key is expected race. And of course, we should return ourselves. So now we have implemented archiving. And if at some point in our application something tries to encode or decode a person object, those methods will be called. In other words, if somewhere in our application this is called and this object is an instance of person class, then one of those two methods will be called. So decoding is the same way. We could decode for key and for a primitive, and I just showed you how to do that. So this is actually we just did, decoding a person, and here we have it. So this is module 1, and if we write just this code and run our application, we won't see any difference whatsoever. So I'm not going to run it because there is nothing changed. But we have this ability to archive, and we will use it because we want to archive and save it into a file. And this is what we're going to do in module 2.